given matrices A and B, we need to use them to illustrate the multiplication of matrices and also the fact that matrix multiplication is not necessarily commutative. So let's start by finding their product AB. AB equals matrix A times matrix B. So in order to find a product of two matrices, we need to find the dot products of the rows and of the first matrix and columns of the second matrix. So for instance, if you need to find the first entry in the first row and first column, that means that you need to find the dot product of the first row of matrix A and first column of matrix B. So we will look at the dot product of these two vectors. Here we have 1 times 2 minus 2 times 1 plus 1 times 2. Well, now we need to find the entry which is in the first row but in the second column of product matrix. So we need to find the dot product of the first row of A and second column of B. So we will look at the dot product of these two vectors. Here we have 1 times 1 minus 2 times negative 1 plus 1 times negative 1. Similarly, to find the third entry in this row, we need to find the dot product of the first row of matrix A and third column of matrix B. So it's 1 times negative 1 plus 0 times negative 2 plus 1 times 1. Well, now we move on to the next row. To find the first entry of the second row, we need to find the dot product of the second row of matrix A and first column of matrix B. So it's 0 times 2 plus 2 times 1 minus 1 times 2. Now similarly, but we need to find the dot product of the second row and second column. So 0 times 1 minus 1 times 2 minus 1 times negative 1. And now dot product of the second row and third column. So 0 times negative 1 plus 2 times 0 minus 1 times 1. And finally, here's the dot product of the third row and first column. So 2 times 2 plus 1 times 1 plus 1 times 2, then 2 times 1 minus 1 times 1 minus 1 times 1, and finally 2 times negative 1 plus 1 times 0 plus 1 times 1. Okay, let's do the calculations. So we get 2 minus 2 plus 2, so just 2. Then 1 plus 2 minus 1, so just 2. Then negative 1 plus 0 plus 1, so 0. Then 0 plus 2 minus 2, so 0. Then 0 minus 2 plus 1, so negative 1. Then 0 plus 0 minus 1, so negative 1. 4 plus 1 plus 2, 7. 2 minus 1, 0, and negative 2 plus 0 plus 1 is negative 1. So this is our product AB. Now we will use the same technique to find our product BA. So now we will multiply matrix B by matrix A. Matrix B times matrix A. So again, we just need to find the dot products. Here we will have 2 times 1 plus 1 times 0 minus 1 times 2. Next, 2 times negative 2 plus 1 times 2 plus 1 times negative 1. Then 2 times 1 plus 1 times negative 1 minus 1 times 1. then 1 times 1 minus 1 times 0 plus 0 times 2, then 1 times negative 2 minus 1 times 2 plus 0 times 1, then 1 times 1 minus 1 times negative 1 plus 0 times 1, and finally 2 times 1 minus 1 times 0 plus 1 times 2, then 2 times negative 2 minus 1 times 2 plus 1 times 1, then 2 times 1 minus 1 times negative 1 plus 1 times 1. Okay, let's do the calculations. So here we get 2 plus 0 minus 2, so it's 0. Then negative 4 plus 2 minus 1, so it's negative 3. Then 2 minus 1 minus 1, so it's 0. 1 minus 0 plus 0, just 1. Next we have negative 2 minus 2 plus 0, so it's negative 4. Then 1 plus 1 plus 0, so it's 2. 2 minus 0 plus 2, 4. Negative 4 minus 2 plus 1, it's negative 5, and 2 plus 1 plus 1 is 4. So as you can see, AB doesn't equal BA because their entries are different. So this proves that matrix multiplication is not all necessarily commutative.